through the different videos you have?
Yeah.
Like different poses.
Oh yeah.
It's like no, I was just scrolling real fast. It's like a cartoon show.
Some weird flip book. All right. Any questions from what we've done, what we did last time?
We redo it all.
That's a good question. Answer's no.
Sorry, you know, I kind of noticed I'm a smart ass.
Yeah, that's all right. Yeah.
So this,
Oh yeah.
divide,
Yeah.
divide,
So they give you a picture, and I'm not going to try to recreate it on the board because I couldn't possibly do it as well as they did. Page 353, they got a pyramid of these spheres, and they're asking, they give you a function that tells you the number of things the number of balls in that sphere, in that pyramid shape, right? So they have a function, you can count them. So they ask you, use the function.
Just slam.
see, I think I did that, well, obviously I did that, but I said I can't.
So you can count it on the picture, right? They give you like a top-down view of the layer. You can just count the layers, right? Count the number of balls in each layer. So the bottom layer is 1, 2, 3, 4, 5, 6, 7, 8. I think, right? And then it's 1, 2, 3, 4. And you can kind of count them through this, and then they give you the function, so they want to know, okay, if it's got 3 layers, because X is the number of layers. So what are you going to put in there if I want to know if it's 3 layers? 3. So then you just throw a 3 into the function and calculate it, see if it comes out. People, when they first look at this, are like, it's going to come out to a fraction. No, it's not. It's going to cancel down to be a nice number, believe it or not. Yep. So that's all I got to do. 2 ways you can do it. They give you a figure to count, or just throw it into the function and get the number out. Cool.
What number was that?
That was 45, page 353. I'm a little slow this morning. I didn't have any of this last night, thankfully, but I did have other beverages that time. 8 o'clock class. Doesn't really go well with that whole process. Any other questions from what we did last time? We got up through 5.2 last time, believe it or not. So, okay, I'm a foolish optimist, or an optimistic fool, so I'm going to assume that's a good sign that there's no questions. Today we're going to do some stuff off of that. We're going to talk about the procedures I have on the handout, the factoring handout. I don't know if you looked at it yet or not. There's a lot of different ways to do factoring. What's up? Did you get that? I handed it out before today.
It was always yesterday.
Yeah, I couldn't remember which day it was exactly. All right. Did you guys look through that? Do you remember some of this factoring stuff?
Somewhere in the back of the brain.
So they split up all the different forms of factoring over a few different sections here. We're just going to kind of go through all the factoring forms first, and then we're going to back up and do some applications. So I want to first talk about how do you factor things, and then I want to talk about, okay, once you factor it, what the hell could you do with it? What does it mean, right? So let's start with the easiest form of factoring, which you've already done. The easiest form of factoring, which on my handout is step 0. You always got to love when we have a step 0, but that just means it's always there. You always try it. The easiest form of factoring is GCF, which stands for cool, greatest common factor. The biggest thing that each has in common. So this one should be like a, oh dear God, give me a lot of those, Jeff. Right? Because they kind of have a certain look to them sometimes. They're just loaded with stuff. Or you just always try it first. Because it's either the only thing you can do, or it makes the problem easier to do. Right? So for example, let's see if we all remember this thing here. So like,
4 squared B.
so like any problem, you take it, you look at the numbers and you look at the letters as they come. The numbers are normally pretty simple. I mean, what's the largest thing that comes out of the numbers? 4. Cool. So you put a 4 here. How many A's can you take out?
2.
Good. They all have at least 2. I know this guy's got 5, but if you try to take 5 from this guy, he's going to freak out. Right? So you're like the, not quite a fair tax man, but at least you don't take more than they can give. Right? So you're a little more fair than the actual tax man sometimes. So you can take out the lowest power you see on each variable. So I can take out a couple A's. How many B's can you take out?
Just the 1.
Just the 1, because the lowest exponent is the 1 at the end there. Little tiny thing, but trust me, this happens. Do you see how I put that over here? So then each of these, if I put that here, I'll forget this guy sometimes. It's a little tiny thing, but trust me, it happens all the time. Now you just write what's left. Now when you distribute something, what property are you distribute a property, but what operation are you doing? Multiplication. So when you take something out, you are dividing it out. Right? So what's left here? I took that 4 out. I had 2 A's. I took them both. I had 7 B's. I took 1 B. I've got 6 B's left. Right? And that's exactly the way you can say it to yourself as you're doing the problem. 16 divided by 4. I had 3 A's. I took 2, so I had 4 B's. I took 1, so I got
2.
How we doing so far, right? Is that cool? Plus, yay! 12 divided by 4 is 3. I had 5 A's. I took 2, so I have 3. I had 1 B. I took it.
None.
How do you know you're done? No numbers come out anymore. This has got B's, that's got A's, so they don't all have the same letter. Right? Okay, cool. The thing that happens a lot with this, let me give you what should be a very simple example. Does that have a GCF?
Yeah.
But I always get somebody that tries to tell me it's this. Which definitely makes it easier to factor, but it makes it very wrong. Because of course, what obviously did they make the mistake doing?
Becomes 11.
Yeah, the 11 has no x. How the hell did you take an x out? How do you check yourself? If you multiply it, it better be the same as it was. And it wouldn't be the same as it was. So you would say this is either not factorable or even better, prime. Cool. All right, so GCF kicks ass, right? Yeah.
And wasn't your greatest common factor?
Yep, it's greatest common factor. So it's the biggest thing that each one of these terms has in common. What factors does this term have? It has 4 and 1, or 2 times 2. It's got 2 A's. It's got 7 B's. Those are the factors it has. What does it have in common with the next guy? What does those have in common with the last guy? The most you can take out, you take. So greatest thing they all have in common that can come out. And it's really just undistribution, right? Instead of putting it in, I'm taking it out. Undistributing, yes. One little thing here before I get to the next kind of level. What about this here? This one throws people off too, believe it or not. Can't see it, I'm sorry.
3G2, 3G the first.
Yeah, so the first step is pretty easy. 3 comes out, 2 G's, and 1 D comes out, right? Because that's the lowest power I see on the variables. What's left here?
3.
G, D3.
D2, 3.
And what I get is somebody does that. Because they say to themselves, oh, I took it away, so it's gone. But again, what are you doing when you're taking it out? What operation you're dividing? So the most direct explanation for why that's not done is because that divided by itself is not 0, it's 1. And the less direct way is that's a placeholder. If I didn't put it there, how could I ever get this back?
Right.
So it holds that guy's place, right? So be real careful about that. I always get somebody think it's just gone. It's not gone. There's got to be something there. There's got to be some reason that guy's there. That's his placeholder. Or you divide it by itself, it's 1. Okay. So let's go up to the next level here. What about this here?
Is this fine?
Could be right.
3. That's 3.
Let me first ask you a question that's not as simple as it might seem. How many terms are there up there?
2.
2. I like it. X plus 5 is one thing, right? If x is 2, that's the number 7. It's one thing. So it's just like 7y squared a cubed minus 14y cubed a squared. It's one thing. When people see that collection, they think automatically 2 things. No. When it's a factor, it's one thing. So what number can come out? 7. How many y's can come out?
Wait,
Good, a couple y's. How many x plus 5's can come out?
2.
2. I like this. Applause in a math class. I like it. Do you see? I mean, it's nothing different. It's the same damn thing. You just treat that as 3 of these things, and then you think the same way. How many of them can come out? So what's left? I took that, I had 3, I took 2, so I got 1 of those left. 14 divided by 7. I had 3 y's, I took 2. I had 2 of these, I took 2 of those, so I got none of those left. You could, but 2y times 1 is 2y anyway. So a 1 factor is not necessary, right? If I put a times 1 there, is it really necessary? It's not plus 1 or minus 1, is it? Because that's times. Right? If it would have been plus x plus 5 squared, I would have had a plus 1. Because there's nothing else. When there's other things, the 1 is not necessary because the other things would be there. If there's nothing but 1, you need the 1 there.
If somebody did that, you wouldn't mark
Well, no. I put a little note.
them.
I'd probably be
Not necessary.
kind of dorky about it, but yeah.
Although if you leave it as x plus 5 like that, wouldn't that make 3 terms now? Without putting it in
I like it.
parentheses or anything?
Sure. Yeah, now in this remainder here, there's officially 3 terms. There's nothing wrong with that. It's when it's a factor of a term that this piece is considered to be one factor, right? One thing. But once I've got it not multiplying anymore, now it comes out that it really is 2 separate things. I really want you guys to see that.
Factor that out the other way. It comes
So watch 8 times 5. How many factors are up there?
1.
What?
2.
So isn't that 8 times 2 plus 3? There's still this number and this number. There's still those numbers, right? But if I write 2 plus 3 by itself, how many terms would you say is up there? How many pieces? There's 2 pieces, right? So when you're multiplying, you consider something in parentheses as one thing. Because it would be one number. But when you're not multiplying, then you can see the separate pieces of the addition problem. That's fine. And I understand that's where people get confused, because it's just a place that people would get confused. But hopefully you guys kind of see what I'm saying. If not, maybe it'll come out as we do some more. And does everybody see that I can treat this x plus 5 as just another variable? Because what is x plus 5? A number I don't know. How many does the first guy have? 3 of them. How many does the second guy have? 2 of them. So how many can I take out? 2 of them. So how many's left of the first guy? 1. So you can put the parentheses in there if you want to, but they're not necessary anymore. Because what did they represent up here? Multiplication of this time. So now I don't have anything to multiply by. So it's not necessary anymore. Okay.
So if you redistribute it, you just have to recognize that it's x plus 5, and then you can throw parentheses on it, like group it together.
Yeah, you could, but or if you redistribute it as it is now, it actually gives you another way that this could be written out. Because couldn't you multiply this out?
Yeah.
And you could multiply that out, and then you could distribute crap all over the place? I mean, okay. But the way it's written to begin with, it's trying to say that this is one thing together. I could cube it if I wanted to, but good God, that's backwards from factoring. Okay. Got a little deeper into that than I wanted to. So what about this here? What, Jeff? I don't know. So now that shouldn't be too big of a deal.
2b times 5 minus y.
Good. Because they have two terms. What does each term have in common? This guy. So this guy can come out. Now here's the cool thing. If you take him out, what's left? 5 minus y. Right? Now some of you guys remember your factoring. We're actually sort of, I'm trying to segue from GCF into the first official factoring method, which is grouping.
Well, this isn't the first official.
Well, it is, but it's sort of like undistribution, so it's something we've already done,
No.
right? So you always try this first. It's something we've already
I
done.
have two of these, just like one I should.
But here's the new thing.
Minus-
Let's see. All right.
Each of the 5 and y get this. It's not gonna
Now, if you look at that, is there anything that comes out of everything? Is there anything that can come out of everything? No. Be really careful about being overly optimistic. This has no b's, so no b can come out. This has no a's, this has no y's, this has no number. So they can't possibly all have something in common. Did you guys see that? But I always get somebody trying to take something out of everything. That's a neat trick. So what the hell can you do here then? You can't do like direct GCF. Some of you guys might see where this came from, but how many terms are there in this? 4. So if GCF doesn't work with everything, you start to count the terms. So you always try GCF first. If GCF doesn't work, or if you did it, you got to then see what's left and see if there's anything else you can do. So once GCF is out of the picture, you say, okay, how many terms are there? If there's 4 or more terms, you try grouping. And trust me on this. You might have been taught to put parentheses in there. That's fine, but it makes it really weird when there's a minus here. So watch, you just say, okay, these two and these two. If you throw parentheses in, do you see how you would cut that negative off? You'd have to change a sign, and it's not always easy to remember to do that. Right? So you're saying, all right, these two and those two. I want to group those. What can come out of these two?
5.
5. And what's left?
A plus
A plus
2b.
Now what can come out of these two? And remember, recall that you're trying to make this what shows up here, because then it can do what we just did up here.
Why?
So grouping is all about making the other parenthesis guy the same as the first guy, so that it can come out. Yeah, they're both negative, and I want them to be positive. So I want to take a negative
Y.
y. I like it. So let me show you a mistake that people make. What would be left here? A. And then I get somebody tell me that this would be this. Now what mistake was made?
Left a negative.
Yeah, it should be a plus because it took a negative out, so that sign should change. But then I get, and please, maybe don't write that down, just watch. Because that's wrong, right? That's wrong. But then I get this. I get 5 minus y, a plus 2b, a minus 2b. Somebody just throw it all together and pray. This doesn't make a damn bit of sense. If you multiply this thing out, you'd have like a ton of terms, not just 4. Can you imagine trying to, you multiply this crap out and then multiply this into that and you get all this? No, this can't possibly be right. But people get a little confused and they get a little desperate and they just throw it all down there. If you get something here that's not the same as there, you made a mistake. I wish more problems would tell me when I was making a mistake. This problem does. This problem says, dude, hey, you made a mistake. Right? You go, oh shit, I took a negative out, it should be plus. Now I'm allowed to do the next step. I'm only allowed to take the next step if these two are the same. And now you see where I got the problem, right? Just multiply that out to make a problem. So what can come out of here?
A plus 2b.
A plus 2b. And what's left?
5 minus
5 minus y. Cool. What's cool is you can take the a plus 2b times the 5, there it is. And the a plus 2b times the y, there it is. Right? Or you can FOIL it out and you would be up here instead. Either way, it's a good way to check it. All right, how are we doing? Okay.
See the glazed look?
Well, I got my own glazed look today, so it's okay. What good. All right.
You see what I'm saying? Same thing, both have it.
Vodka better.
Both have y and 5. Both have this.
or
So when you factor it out, just.
So you guys try this problem here.
Minus bm. It's the same idea. This has got to go to both.
Let's see. This is always scary to try to make one that works here. So again, you always say to yourself, can anything come out of everything? Is there anything that can take out of all four terms? No, right? This has got X and D's, that's got A's, 15 has nothing in common with 4, so no letters or numbers can come out. When that happens, you say how many terms are there, and that actually tells you what to do. When there's 4 or more terms, I group. Right, so grouping is really just a couple of GCF problems in one. And GCF is the greatest factoring method ever. It's pretty simple. Should be.
GCFE,
GCFE?
greatest factoring ever.
Okay, that's close. So what comes out of the first two there?
2XD.
2XD. And what's left?
2x.
2x minus 3. I like it. So you better get a 2x minus 3 here. So what comes out of those two?
Plus 5a. 2x
2x
minus 3.
I just gotta say I'm proud of myself that I made it. But anyway. How do I know it works? Because that's the same as that. If those weren't the same, I either made a mistake or it's not factorable, right? So, of course, what comes out?
2x minus 3.
And what's left?
2xD plus 5a.
Plus 5a.
Cool. Now, really be careful. How do you know you're done? Because neither one of these can go any further, right? Because if there would have been a D here, I should have taken a D out of this also. You just gotta, every time you do something, you just make sure that's actually it. Say, is anything else, can you go further? So the idea behind that is if I said factor 18 fully, would it be right to say that's 3 times 6?
Nope.
No.
No. Why?
2 times both divisible.
6 goes further. 6 is 2 times 3. So that would be the complete factorization. So that's why if you do one thing, it doesn't mean you're done. Make sure nothing else goes further. Cool. Okay. Here, try. Let me give you one. It's a little bit more interesting. Here we go. Cool. I'll make it more interesting. Oh yeah. Here's one that's got a little bit of a twist to it. start to realize the first grouping is your friend. See what he tells you and do what he says, right? See if you know what I mean. You're all like, what the hell are you talking about? I'm talking to freaking math professor. So here, nothing comes out of everything, right? So there's 4 terms. That's what tells me to do this. What comes out of these 2? I like it. What you notice over here is, and it's okay to make a mistake. If you say, okay, a 2 comes out and you do this, what tells you something went wrong? Yeah, these are not the same. Why are they not the same? One is the negative of the other one. So you've got to realize what it's trying to tell you. You say, oh shit, I should have taken a negative 2 out. That would have made these the same. Right? It's kind of like in the wrong order there. So if I take a negative 2 out, that makes that become a positive A, and that become a negative 3. That's the cool thing about these problems. You don't have very many problems in mathematics that the problem itself says, hey, you're making a mistake over there, right? So you look at this guy, oh, now they're the same, so now I can do the last step. That can come out. I like it. Real quick, let me do this on this problem, just because I want to. Let me show you something you normally don't see. This is very abstract, obviously. Right? And that's why, one reason why people hate this like crazy. You're like, I know what I mean when I say factor 18, I can do that shit, but this is weird shit. And you don't even know the connection between those two. They're actually the same. What is this whole thing if I knew what A was? If I knew what A was, what does this whole thing represent? A number. And I can factor any damn number. Even if it's 17, it's 1 and 17, right? That's the way to factor it. So watch this, it's cool. That problem's done. I really want you to understand you never have to do what I'm about to do. It's just I want to show you what you actually just did. What if A, I can make A anything I want to, of course. It's a polynomial. A could be anything. So let's say, just because, let's say A equal 5. So somebody help me out. What number would this be then? 5 cubed is 125. 5 squared is 25 times 3 is 75. Plus 6. Minus 10, I like it. So what number we got? 50, 46? How are we doing so far? Right? So if A is 5, this number is 46. What is this? What's that right there? 46. If A is 5, this is 2. 5 squared
25.
minus 2.
23.
Is that a way to factor 46? Okay. Have you guys ever seen that before? I don't know why. I try to tell my colleagues, you know, you should show them this. I mean, do you like seeing that? I mean, it makes it more concrete, right? What you've actually just done. The reason this is harder is because how many numbers do you actually factor when you do this? You factored an infinite number of freaking numbers. So if you run into a friend later today, said, you know, what'd you do today? I factored an infinite number of numbers. This one. What'd you do? Right? Because you say, I can make A whatever the hell I want it to be. Some of the factorizations will be lame. It'll be like 1 times 80. Like, ooh, that's amazing. But you got to give it a break because you're doing an infinite number of numbers. They're not all going to be kind of cool like this one. 46 is 2 times 23. That's freaking awesome. Do you guys see what I'm saying? Notice something. If A is 3, what would this be?
0.
0. So if A is 3, this better be 0 also, right? Does everybody see that? So if I know that, like, if I knew, I'm trying to get us ready for stuff later. If I knew x equals 7 made some expression 0, I'm trying to use our notation. If I knew that that made this 0, what factor should be in this? So, I know that 3 makes this 0. If I throw a 3 in there, I get 27 minus 27 is 0. 6 minus 2 times 3 is 0. The whole thing's 0, right? And sure enough, that means that this better show up, because 3 minus 3 is 0. So if I know that 7 makes it 0, what better show up in here?
Minus 7.
X minus 7, maybe some other shit, right? But that better be in there. Do you guys see that? That's the connection between what the hell we're doing. We can kind of, once you factor something, you can see what makes things happen better than just looking at that crap. That's one little reason why we factor things. It's good to know the pieces that go into something. Because then I can analyze each piece a little easier than I can analyze the whole damn thing. Alright, alright. Alright, so that was a major side note. What about this guy?
We do, actually, a couple different, we do factoring and then grouping and factor.
What do you always try first?
Factor,
GCF, right? Does anything come out of everything?
choosing,
I like it. So a 2 comes out and a Z comes out.
and then, 2xy,
Good, so now you got 2xy, because the Z's gone. I took a 2 out.
minus
2's gone.
x squared y,
The Z's gone.
minus 6,
Good, because 2 makes it 6 and the Z's gone.
plus 3x.
3x, because 2 goes into 6 3 times, the Z's gone.
And
You're not done, because now you look at this and this. And I'm hoping I do. Oh, I can't remember which problem. It's good, we'll see if it works.
It works.
Oh, it's good, thank you.
I already did it.
Because I was trying to take a problem from the book and modify it. It's always a little iffy. Now here's the thing. Don't lose this poor dude, right? So like earlier when I said 18 is 3 times 6, 2 times 3, you wouldn't say that. 18 is 2 times 3. What? I'm worried. Don't lose anything you've already done, right? That should be a part of it. So you took a 2z out, it better come for the ride. So in here, what comes out of these two?
xy,
xy, I like it.
and then times 2 minus x,
Right? Cool.
minus 3,
And then minus 3 comes out.
and 2.
And of course, you're taking a negative 3, so you make that 2 positive because of what the little dude tells you. And that's going to make that negative now. You guys see that? And this guy comes for the ride still. He's like, I'm done. Come on. And then what comes out of here?
xy minus 3.
So 2 minus x, yeah. And does it really matter if I put the xy minus 3 first? No, it doesn't matter because that's commutativity, right? So that's not the only right answer. You can put that first and that second. That's cool. How we doing? Is that? Some of you guys look bored. That's good. Maybe you know this stuff already. Just hang out. All right. Some of you guys are like, I'm not bored, dude. I'm just like, what the hell is going on? Alright, good. Let's see. I don't think they get too freaky yet. No. Nothing too freaky. Yeah, well, here's one little thing. What if they did this to you? Separate you two.
Sorry. We're comparing shoes. I should have, I messed up and put on 2 pairs of shoes this morning.
Oh, 2 different pairs. Like the movie The Man with One Red Shoe. The one with one slightly larger sandal. Alright, so maybe reprioritize things. Don't compare shoes. What's going on here? I mean, the way it's given to me, can I do a next step? Exactly. So this is a problem where the problem starts here, and you're like cleaning up somebody else's mess. Somebody started a factor and said, "Oh, what the hell to do?" You're like, dude, all you did was these aren't the same. You got to take a negative out of there so it makes it reverse, right? So you leave this guy alone. Take a minus out. So now that negative x is positive, that y is now negative, and now these are the same. So some of these are like, when you play Tetris, you can play where it's already halfway up. You ever play Tetris anymore? You know, you got to start with somebody's mess is already there, and I always kind of like to do that so I can clean up the mess. Here, that's the same thing. You're starting, somebody else messed it up. You're like, all right, screw you. Just, you made a mistake, take a negative out. And then what's the last step here?
X minus 1.
I like it. Cool. You can always check yourself by multiplying it back out, seeing if it's the same as what the first one was. Okay, cool. So that's grouping. That's not too bad. So if you're following along our little list, You always look for greatest common factor, and if it's 4 or more terms, you try grouping. It's the next level, the 3 terms, that people normally think of if I just say factoring. Everybody thinks of x squared plus 7x plus 12 or something, right? That's what first comes to mind, normally. So just so that everyone's on the same page, I know a lot of you guys already know exactly how to factor that problem. So make sure everybody's on the same page. Let's first get a little motivation about how to factor something that looks like this, where A is 1. That first number is a 1. Some of you guys might remember when that first number is not a 1, it gets a little bit more difficult. Okay. So what I mean by that is an example would be, like I just said, x squared plus 7x plus 12. So let's hold off on that for a minute. Let me give us a little motivation as to why it works. Where would something like that come from? What would I have multiplied by to get something like that? I would have multiplied by, a couple of things like this, right? I'm not saying that's the answer. I'm just saying this is where something like that would have come from. And when you multiply this, what do you get?
X squared. 7x.
Where'd that number come from?
5 times 7.
That number times that number. In fact, the last number will always come from that number times that number, right? Where does the middle number come from?
X times the number.
That number plus that number, right? So that's why the method we use works, and you all have heard this. Find 2 numbers that multiply this and add to be this, right? Or the product of them is this, and the sum of them, whatever. This is why. Why? Because that's what frickin' happens, right? If you take any binomial times binomial, it's going to have the same pattern to it. The middle thing is going to come from those 2 added. The last one's going to come from those 2 multiplied. Cool? So, if I want to try to attack this, I got to think backwards. I've got the result, so 12 must have been the product of 2 things. And 7 must have been the sum of those same 2 things. And in fact, think about it like this real quick. How many numbers are involved that I don't know? Because what goes in the first place? What goes here? X and X, because that's how you make X squared. So there are 2 numbers I don't know. I need 2 pieces of information to figure them out. And I got the multiplication, and I got the so what 2 numbers, of course? 3 and 4. So 3 goes there and 4 goes there. They both have to be plus to make it everything plus. Cool. The funny thing is, you guys normally make a list of factors of this thing and see which ones add up to be that. You normally don't realize you can make them add first. That's easier, especially when that number is disgusting. For example, before I get too far, let me give you another one of these to try. Exactly. It's not too many ways to factor 26, right? So it's kind of nice. So you can always start off with x squared, so it's got to be x and x. So you're trying to fill in those blanks. I like it. So 26 is 13 times 2. Your whole deal now is, because 26 and 1 doesn't work. There's no way that can make 11. But 13 and 2 would make negative 11 as long as the 13 is negative. The bigger one is negative. Cool. So this should all be very familiar somewhere in the deep recesses, maybe. And you could do the same thing we did earlier. If you let x equal 4, you can kind of see if that'll be a number, and this is a way to factor it, right, like we did earlier. That's kind of a nifty way to check it if you had time. All right, so what about this here? Let me make one nice and disgusting. All right, Jeff.
Be afraid, be very afraid.
What's that?
I said be afraid, be very afraid.
Yes, you should be. All right, let me see. Now, before anybody goes blurting out the numbers, because I know there are some of us who are better at numbers than others. That's just the truth. Some of us just work with them more, or whatever. I want to show you a nice universal way to do this. And if you're better at numbers, there's shortcuts you can take, but that's up to you, right? Why would it be kind of disgusting to try to make a factor list for this? Because there are a ton of them, right? What's one thing I know about the two numbers, though, since that's a minus? The two numbers have to be different signs, right? So here's what I mean. I just need two numbers that do what? They multiply to be negative 480, and they add to be 4. When people teach this, it's like they say they got to multiply first. No, they got to do both. I don't care which one they do first. They just got to end up doing both. What the hell do I mean? I mean, what two numbers add to be 4 if they're opposite signs? Let me start us off. Wouldn't 16 and 20 add to be 4 if the 16 were negative?
Yep.
So it works for this. Does it work for that? No. 16 times 20 is not negative 480, right? It's 320. It's too small. So maybe up my numbers. What about 18 and 22? That makes 4, right? They're 4 apart. Do you guys see that? Well, when you multiply that, you get 396, I think.
Yes.
Yes, okay. Look at that, my brain is working. But do you see how I'm getting closer? Sort of like the Price is Right game, the higher and lower crowd. You can see yourself getting closer to what you want. And of course, it's going to be 20 and 24. And that makes negative 40. Have any of you guys ever seen that? Has any of your teachers shown you that? Good, I like it. So a few of you guys, very often I get nobody did, but this is cool. Because it doesn't matter if you make it multiply first and then check to see if it adds. Why don't you make it add first? That's a lot easier. And check to see if it multiplies, especially when that last number is disgusting. Right? It's a lot easier to come up with a list of numbers that are 4 apart, and then you just see what's happening and see if you're getting closer. If this would have been negative 200, I went, oh shit, I'm getting further away. Let me change them the other direction. Right? So it's like a nice little game now. So what the hell does that mean, what we just did? This works. So what's the answer? I like it. Cool. So let me see if you guys can tell me this. What does it mean if I graphed this? Can anybody tell me where it would go through the x-axis? You can just look at this and tell me.
20.
At 20, it would go through the x-axis, right? Because at 20, it's 0. Can you just look at that and say at 20 it's 0? No. And again, that's why we break it into parts, because it's easier to analyze. Also at negative 24, it would go through 0. Right? So I could actually graph this parabola a little bit. At 20, it goes through 0, and at negative 24, it goes through 0, and whoop, there's the parabola. Because it opens up, right? I mean, that's in our future, but you guys can see how that connects. Once you factor it, it's easier actually to graph it.
So it's 20, not negative 20 for the first
Because
one?
what makes it 0? Positive 20. Because you think yourself, you're trying to say what makes it 0, so you add 20.
Okay.
So it's going to be the opposite side of this to make it cancel. Cool. Right? Again, it's a little bit ahead of where we are right now, but that's the connection we're working towards. Because I always get some, not smart ass necessarily, somebody saying, why do we do all this shit? Well, there's one real reason why, right? There's a lot of other reasons why, believe me, but we're going to work on them. So here, let me shut up for a minute and let you guys do a couple of these. And again, just to let you know, we're going to do several sections today, and we're not going to kind of complete each one. I just want to show you all the forms of factoring and then go back and fill in the applications of factoring, right? So we're going to kind of go through several sections and then come back and finish them out. Don't know what I mean, just take good notes. So on page 390, let's try, yeah, sure, 12.
Hey Jeff, you know how to do it, I think my teacher called it like the X factor or something, where you put an
Master
X?
product, yeah.
Yeah.
If you want to do it that way, personally, I don't see the usefulness, but if it makes it better for you, cool.
I saw you.
Just a general note, if you guys do any method, I think, did I already say the one method that I don't accept? Good, so if you don't know what that is, keep it that way. There's a method of factoring called bottoms up, which if you can explain to me why the math works, I will let you use it.
But nobody has.
Nobody has. The numbers, you do some division and it pops out the numbers. I don't like it because it doesn't teach you a damn thing, right? Once you know how to do it, then I would do bottoms up method because it's quick. But right now, what are you doing? You're learning this shit, and that doesn't teach you a damn thing, right? So if you know bottoms up method, too bad, put that away, learn something else. Actually learn now, right? All right. That's a saying against your teachers if they showed you that way, but all right. What? Yes. Let's see what you think about this here. Yeah, that's a good idea. That's fine. They like the number right there. Hmm? No, it's been up there. It's okay.
Probably, I was reading that one when you were reading that one.
Oh, yeah. Do you see the connection between 12 and 34?
Yeah.
I wanted to make the point about 34 looking like it's loaded with too many letters, but it's very easy to take care of that. So how do you do 12? Yeah, 27's really only got a few ways to factor it, and the way that makes 12 happen is, I like it. If that would have been a minus 12 in there, what's the only thing that would have changed? Or you know, a couple things changed. Yeah, that would have been both minuses now, right? To make it negative 12. Right? Cool. Okay. So what about this guy here? Yes, GCF always first. I know I'm guilty of knowing it's not a GCF, and I don't even say it, but here, this had no GCF, that's why we didn't do it. What can come out of all three of these? A 2. You're left with? Oh, 32, yeah. Oh, no. Yeah. Shoot. What I get though is somebody does this is their first step, and I'm not sure how they could do that because they don't even know what's left once you take a 2 out. They try to go to this step immediately. No, take a 2, see what's left, now attack this. And of course, what's the factors of 16 that make 8?
Minus 12.
Good, they both have to be negative to make negative 8. So who knows, what's a little bit better way to write this then?
Square.
Square, I like it, right? Can you tell me what's interesting about that parabola then if I were going to graph that? How many times does it hit the x-axis? In this case, the a-axis, but... What makes it 0? Just 4. Right? You can see that? Like up here, it would hit it at -9 and -3, right? So I can hit -9, -3, and then graph it. Here, it only hits it at 4. It's the only thing that makes it 0. So it'd be a parabola that's, I know what you mean, but the only way to make it sideways is to kind of change the x and the y around. This would be a parabola that's sitting on the x-axis. So this is not really sufficient. I've only got 1 point. I should get a couple more points to make sure I got the parabola fat enough, right? Or skinny enough. You guys with me?
Yep.
If I have both intercepts, all I'm really missing is the vertex, and again, that's in our future, to really make a good graph. Do you have to know any of that crap I just said? No. That's the answer to that. It's factored. Now, the connection between these two, well, they make it an x instead of a y, but they have an extra y squared at the end. But that's pretty easy. X squared is x and x. Y squared is y and y. You just got to figure in the numbers. We already know the numbers. 9 and 3, right? So if there are squared letters at the end, you just put an extra little letter at the end of each piece. So you pick up a y squared at the end. How's that? Cool. Maybe.
So what about that 12xy?
I like it.
You don't put the x down?
Put the x down where?
9xy.
What happens here? Doesn't it pick up an x?
Oh.
When you start to FOIL it out, the middle
okay.
terms better be xy's. They will be 9xy's, 3xy's,
Okay.
12xy's. So as that cross multiplying that actually makes that middle term come out right. All right, cool, cool, cool. Okay, let's do one more form of factoring, and maybe we'll take a, I don't know, you guys want to take an early break? Or you want?
Yeah, that sounds good.
I get this sense from you guys. I can feel it. All right.
Is this still 5-3?
We're all mapped out.
Jeff?
Can we just take a break till tomorrow?
Tomorrow's Friday.
Friday.
I know, and we'll do homework at home.
I like that. You want to come back tomorrow?
No, I don't wanna do my homework at home.
You guys can elect. You can elect a teacher for tomorrow. I get to be here.
Is this still 5-3, Jeff?
Still 5. Well, actually, we're 5-4.
Okay, cool.
And again, like I said, we're going to look at all the forms, and they've spread out all the forms over several sections. So I'm going to cover several sections of factoring form, and then there's a few more ideas in each section. So what do you do when you have something like this when the first number is not a 1?
Freak out.
Oh,
Freak out.
yeah. You no, you don't want that. You don't want me singing or dancing. Here's the thing. We're gonna get a little motivation. We're gonna so it'll be something like that. Is there a GCF? So remember, we did a problem that had a 2 in the beginning, but it wasn't one of these types because I could take the 2 out. So you go, please let me take the 6 out. Screw you, 11. So then it's going to be a little harder. The reason it's harder. What's up?
Nothing, I know how to do this.
Oh, good. Okay. Really? All right. So I always feel like I'm in an acting class when I do that, but a little motivation as to why it works. And again, we're going to kind of analyze it the way we did before. Where would something like that come from? It wouldn't come from just like x plus 7, x, let's say, minus, let's do plus 3. It would have to have numbers out front here also, right? So maybe like 4 and 2. So let's see why it's not going to be as easy as it was when there was just a 1 out front. Here's why. Here I get my... So again, this is not what that is, right? This is just an example where something like that would come from. 8x squared.
12x.
Now, so then the last number is still these two multiplied, right? But is the middle number going to be these two added? Hell no, it's 26 freaking x. Holy shit. Right? So why is the middle number not 7 plus 3 like it used to be? The middle number used to be, this is 12, and that's 9 plus 3 is 12. Yay. They made it really easy. Now, 7 plus 3 is 10, not 26. Why is that? It's a very simple answer. Hopefully you guys...
Because the first number's
Because these mess up my middle term numbers, right? It's not 2, it's not 3, it's 4 times 3. It's not 7, it's 2 times 7, right? So, when you go to factor this, you have to take that first number into account, because it's the pieces of 8, 4 and 2, that messed up my middle term, right? It multiplied my middle term and made it come out bigger when I added it. So it's somehow we have to take into account that 6 in this problem, for example. That 6 has got to come into play to help me figure out. In fact, let me see if I can point this out. 12 and 14 is 26, and 12 times 14. Now here's the interesting thing. What is 8 times 21? 168. What's 12 times 14?
168.
168. Right? So 12 times 14 doesn't equal 21. It actually equals this times this. So over here, I can't just find factors of -10. That won't work anymore. I've got to take this into account. I've got to first multiply 6 by this. I need factors of -60 that make 11. So I have to take into account that first number. And actually we do over here too. Because what's 1 times 27? 27. I mean, so it doesn't change it if it's a 1. That's why it's easier if it's a 1. If it's not a 1, oh shit, it changes everything. So let's see if we can get this. What factors of 60 add to be 11?
4 and 15.
-4.
I like it. So 15 and 4. Which one's got to be negative?
4.
4.
The bigger one's got to be positive, right? So 4 is negative. Now here's the trick. You cannot go right to the answer because you don't know if it's going to be 2x and 3x or 6x and 1x, right? There's a few different ways to get 6x squared. There are shortcuts to this. There are other ways to do this problem. But I like showing this method because it always works. That's why I call it a surefire method. There's no real guessing involved. If you looked at my little list, it's called a surefire method. That's the name I was told when I was taught this. Surefire. So if I take this guy here, here's the idea behind surefire. 3 terms sucks. 4 terms is easy, isn't it? 4 terms, just group the damn thing. So I've got a way to break 11 up that will make grouping work. This. I can break 11 up like 5x and 6x, right? Right? But the grouping won't work. That's the only way the grouping will work. So if I make this 6x squared, so 11x is 15x minus 4x, right? So the whole point of surefire method is to take an ugly 3-term problem and make it into an ugly looking 4-term problem that we know ain't ugly. It's grouping, that's easy. You guys see that? So as long as you know what your goal is, it makes the middle part easier to remember. I mean, that's what we're doing that for. So what can I do with these first two?
3x.
3x,
I like it.
2x, negative 2.
Good. You want to take a negative out to make them both positive. So now these are the same. And again, it doesn't matter if you make it 3x minus 2 there, it doesn't matter, right? What order they're in.
Why is this not taught like this?
I don't know. Now, again, I just want to make sure you guys understand. Some of you guys, I'm sure, right now are saying, why the hell is he doing all that shit? I did this way. Some of you guys are really good at what's called trial and error. You just, okay, 6x and x, so let's try 5 and 2. If that doesn't work, let me try 10 and 1. You see, you're finding factors of this and factors of that and seeing that what makes the middle term work. If you're not good with playing with numbers, this will take you forever. If you are good at playing with numbers, like I said earlier,